Welcome back. We're going to start Unit 3 today. Day 1, we're going to classify different states of matter and differentiate between physical and chemical changes. First, we're going to start with matter and change. Matter is anything that has mass and it takes up space. So gas takes up a space, liquid, and solid. What are 3 examples in your room that would not be classified as matter? And remember, matter has mass and it takes up space. First, we can say light, because it's a wavelength emitted and you can't see the wavelength. All you see is the energy emitted from the light. Next would be sound, because you can't hold a song. And then last would be heat. It's something that you feel, but you can't hold it. So basically the things that aren't matter are waves. Radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, gamma rays, so energy in general. And air is a matter because it's a gas, and if you condense it like into a balloon, then it would take up space. So there are 3 basic states of matter. You have your solid, which is written as an S, has a definitive shape and volume. Liquid, which is an L, can change its shape, and it still has a definitive volume. Gas changes shape and volume to match its container. So the whole cats are liquid fits into its container. So let's draw a representation of the molecules in the 3 states of matter. A solid, so let's imagine a Lego. Your little Lego has your 3 little dots. And the particles that are in it, because it's a hard solid, are very close together. They want to stay as close as possible together. So it would look very dense, like this. A liquid, let's look at a bucket of water, are kind of spaced out. They're kind of free moving. And then your gas, let's say it's in a balloon, they're bouncing everywhere. And that's why it has pressure. Pressure is always involved with gas. Pushes against its container to get as far away as possible from each other. Matter can change from one state to another. There are 6 possible state changes. For each, the energy is either absorbed or released. The 6 state changes are: you can freeze, sublimate, condensate, melt, evaporate, and deposit. Think of your water cycle. Whenever you have a river that freezes over, it becomes a frozen river. Sublimate is going from a solid to a gas, which is like your dry ice. Condensate is like whenever you're taking a hot shower and you can see the little particles that are on your mirror. That's whenever the gas in the air condenses into a liquid. Melting is like after it's snowed and all of your snow starts to melt because it gets too hot. Evaporate actually happens at the same time. So whenever that snow melts and drifts off, some of it is being released as a gas as well. And deposition is just your rain. So there are 2 kinds of changes. You have your physical change and your chemical change. Physical changes are usually reversible and can be undone. All state changes are physical changes. So your water cycle is a physical change. Dissolving is a physical change, and changing shape is also a physical change. So for dissolving, these are the 3 different ways we can change back into our original physical mean. You have filtration, which separates components based on their size. Distillation, which separates components based on their different boiling points, which is good for dissolved substances. Chromatography, which separates based on differences in solubility. So filtration uses a very fine filter paper, usually between 10 microns to a centimeter in diameter, depending on what you're trying to filter out. And here you can see you have a funnel. You usually put your filter paper in and then you pour in your solution, and it holds the solid residue, which can't fit in the filter paper, and releases the liquid filtrate. Distillation purifies a liquid by heating and cooling it. By heating it, the gas vapors raise and condensate in the condenser and turn into a pure liquid. An example of this is petroleum distillation, where increasing amounts of heat, so we would turn up our burner, allows different fractions of gas to be released from the crude oil. And then you have chromatography, which separates compounds of a mixture by traveling at different speeds vertically on a piece of paper and separates their components. Larger molecules will travel slowly from the solvent, and they usually stay towards the bottom. So see how it's heavier in color here? And the lighter molecules come towards the top. So for the first example, if you had sugar and water, how would you separate them? We can dissolve sugar into water and it still comes out as a clear liquid. And to get rid of it, think of the method that easiest removes something dissolved into it. It would be distillation, because the sugar particles are way too fine to be used in filtration, and it doesn't have a color, so you can't use chromatography. And if you wanted to separate the colors in a black marker, how would you separate them? That would be chromatography, because it says black marker, so you're using a color. And if you've ever noticed, you can draw something black, and if it rains on a poster or something, it usually leaves like a line around it. And that's just where the water has separated its components. If you wanted to separate sand and water, what would you do to separate them? So sand is a very fine particle, and if it's sitting in the water, then you could use a filter, and it would leave the sand in the filter and remove the water. So it would be filtration. Chemical changes produce a new substance, and the new substance will have different properties. Evidence of chemical changes include color change, bubbles, which is the formation of a gas, a new solid forms, which is known as a precipitate, and the temperature can change, which is the evidence of bonds breaking or forming. Chemical changes are also called chemical reactions, and chemical reactions always produce a new substance. So this can be done through rusting, burning, reacting, cooking, digesting, combusting, and so many more. It's the fun part of chemistry. Your properties of matter is something that you can observe or measure. There are two types of properties. You have your chemical properties and your physical properties. Physical properties can be measured or observed without changing or destroying the samples. Examples of physical properties include mass, density, boiling point, malleability, color, melting point, and ductility. Malleability is the ability to bend a metal, and ductility is the ability to turn it into a wire. There are two types of physical properties. You have extensive, which depends on the amount of substance, so your mass, length, and volume, or intensive, which stays the same no matter how much of a substance you have. This includes color, density, and conductivity. So imagine you have some chocolate. You can go get some, follow along. What are the intensive properties of this chocolate? Remember, intensive doesn't change and extensive does. So your density would be one that didn't change. It's always going to have the same square bar, is always going to be the same inside, unless you happen to get one that has an air bubble in it. It's always going to be the same. Its color, unless you have M&Ms, the inside of the M&M is always going to be brown, and a Hershey bar is always brown, unless it's white chocolate. But we're talking about regular milk chocolate, the good one. Its melting point would be another intensive property. It never changes no matter how much chocolate you have. If you hold it in your hand, it will start to melt, so it has a pretty low melting point. And its conductivity. Chocolate will never conduct electricity. It doesn't do that. Extensive properties of chocolate include volume. So if you have more of it, you're going to have more volume of chocolate. So a bucket of chocolate versus Willy Wonka's river of chocolate. Your volume will increase the more you have. Its mass, which is the same thing. You have more of it, it's going to weigh more. Its weight, which is gravity times your mass, is the same idea. You have more, it's going to weigh more. And if you have less, it's going to weigh less. And its size. Like the guy that does chocolate statues, the one with the dragon coming out of it, versus just a regular old Hershey bar. You can change its size by increasing its amount. Your chemical properties are how much a substance reacts with other substances. This cannot be measured or observed without changing or destroying the sample. These are easy to recognize as they always react. Examples of properties is your reactivity, which is how exactly it reacts, flammability, combustibility, oxidize, or corrosive. Your oxidizing is how it reacts with air, and corrosive is how it reacts with acid. Remember, oxidize has O for oxygen. So let's do some examples. The first one is the water in a brook freezes every winter. Is that a physical or chemical change? It's going to be a physical change because water freezes at 0 degrees Celsius and it doesn't change its chemical makeup. It's still water. So here we have an apple where this part had a lemon rubbed on it and this part didn't. So the apple oxidized with the air, which is why it turned brown. Do you think this is a physical or chemical change? Our clue word is going to be oxidize. And we know that oxidation is a chemical reaction. So your answer is chemical. So here we have a cliff, and it says that water has eroded the cliff. And here you can see where the water actually ran down in these grooves that are right here. Is this a physical or a chemical change? This would be a physical change because the water didn't change the makeup of the rocks. It just changed the way it looked. Here we have water from the air that has cooled and condensed onto the blades of grass. Is this a physical or a chemical change? This is going to be a physical change because we know that our water cycle is a physical change. So the fact that there's water here doesn't change the fact that the grass is still grass. It's a physical change. As the blades of grass grow older, they turn brown and droop. Is this a physical or a chemical change? This is actually going to be a chemical change because it's a change in the color of the grass. Photosynthesis is the process of changing light, carbon dioxide, and water into energy for the plant. So whenever it's brown, it's a lack of photosynthesis. Sublimation is the process of converting a solid directly into a gas, or a gas into a solid. So this is like dry ice. Is it a physical or a chemical change? And we know that our water cycle is a physical change, so the answer is going to be physical. When water evaporates, minerals and salts are left behind. Is this a physical or a chemical change? This is going to be a physical change. Salt can be dissolved into water, so when the water evaporates and leaves the salt behind, it's a physical change. It has not changed the chemical makeup of either the salt or the water. And here's another look at it. The salts appear to be white and brown. It's kind of hard to see, but here you can see like some brown spots. Is this a physical or a chemical property? This is actually going to be a physical property because salts can be different colors. And it's going to be intensive because we're talking about color. It doesn't matter how much salt makes up this thing. It's always going to be white or brown or pink or black. There's a lot of different colors of salt. Sulfur and phosphorus can burn just like paper does. Is this a physical or a chemical property? The cool thing about sulfur and phosphorus is like if you expose a perfect element into the air, it will immediately combust. So this isn't like we lit it on fire with a lighter. This is phosphorus in the air. And this is going to be a chemical property because burning is a chemical change as it turns sulfur into sulfur dioxide and phosphorus into phosphorus pentoxide. Here we have a soda with a bag attached to the top, and the carbonation from the soda, which is your little bubbles, are moving through the lid and into the bag. Is this a physical or a chemical change? This is going to be a physical change as the gas is just leaving a solution. It doesn't change the makeup of the soda. Here we have ice. We know water melts at 0 degrees Celsius. Water freezes at 0 degrees Celsius. Water boils at 100 degrees Celsius and condenses at 100 degrees Celsius. Are these physical or chemical properties? These are all part of your water cycle, so we know that these are all physical properties. Pancakes turn brown when they come in contact with intense heat. Is this a physical or a chemical change? This is actually going to be a chemical change because you go from this liquid batter into a nice toasty pancake, and you can't reverse that. So it's changed indefinitely. Since gold is more dense, it will settle to the bottom, which is here we have a miner panning for gold. Is this a chemical or physical property? This is going to be a physical property because density doesn't change based on the amount that you have. And here we have a piece of bread, and here we have a piece of moldy bread. Is this a chemical or physical change? This is actually two chemical changes. As the bread decomposes and mold eats away at the sugar, water, and minerals in the bread, it breaks it down. Both are irreversible and both cause a stench to come from the decomposing bread. So it's going to be chemical. You can't reverse it. When underground water is used up or minerals are mined out, sinkholes can happen. Is this a physical or a chemical change? This is actually both, but the chemical one is a little bit more complicated. Physically, you can remove water from underneath of a sinkhole by pulling water out of the water table, or it can be removed by mining, and this causes a pressure difference, which causes the land to sink. The chemical version of it is called karst topography, and it's fossils that make up a layer underneath the ground. And this layer is made up of calcium carbonate. And whenever rainwater goes through the soil
and reaches this calcium carbonate, it's washed away because calcium reacts with acid and dissolves, which is the chemical component of this. But that's just a fun geology topic. Soil is brittle. Is this a physical or a chemical property? The soil horizons, which are your layers, are physical properties. What effect does acid rain have on statues? Well, I just told you that acid rain washes away calcium carbonate from underneath the ground, and because we can see that the acid rain has washed away her features, this is a chemical change, not physical. Chemical change. Rocks can melt. Is this a physical or a chemical change? Similarly to our water cycle, the rock cycle can change from magma to hard rocks and back through different geological processes. It doesn't necessarily change the chemical makeup unless something else is introduced to it. But for the most part, it's a physical change.